All right, so this video will focus on 3.2, and this is the extension version of that. So it starts off with looking for the greatest common factor. And if I look here between 2 and 10, the very first thing you're going to do is go through and I have like 1. So 1 times 2. For 10, let's think of prime factorization. So I'm going to go through here and put a 10 down. And I can take out a 2, and then a 5, and then a 5, and a 1. So for this one, it would be 1, 2, and 5. So the thing that they have, the greatest common factor that they have, will be this 2 here. So if I would take out a 2 out of both of these, I would have 1 and 5. So let's look at the next one here. And we have 3 and 24. And of course I have 1 times 3. And then my prime factorization of 24 would be 2, 12, 2, 6, 2, 3, 3, 1. And so I'm going to put that down here, and I'll put down my 1 times 3 times 2 times 2 times 2. And so my greatest common factor I have would be my 3. For the next one is going to be 9 and 27. So I'm going to go through and do the prime factorization, which would be 1 times 3 times 3. And then for my 27, if I do the prime factorization of that, I'll have a 3, a 9, a 3, a 3, a 3, and a 1. And I'll put these down. So I have my 1, 3, 3, 3. And what they have in common, if I look at that, is I actually have this 3 and 3. So 3 times 3 is 9. So the greatest common factor here that I have is 9. When I do 14 and 49, I'm going to have 2 and 7 will be my 14. And then for 49, I can take out 7. I get a 7 and a 1. So this would be, and this is times 1. So this would be a 1 times 7 times 7. So therefore my greatest common factor here is 7. 24 and 42, when I do that, I get 6. And then finally I get 10 for 50 and 90. And the reason why we do this is because I'm actually looking for the greatest common factor to take out of this. I want to factor this out. So I'm going to go through, and I first of all want to think, what can I take out of 24 and 18? So I'm going to do prime factorization of 24, which would be 2, 12, 2, 6, 2, 3, 3, 1. So my prime factorization is 1 times 2 times 2 times 2 times 3. And then I'll do another color here. And I'll do 18. If I do that, I have 2, 9, 3, 3, 3, 1. So I'll put this down here. And I have 1 times 2 times 3 times 3. And the thing that they have in common here, if I look at them, is they both have the 2. And they both have a 3. And 2 times 3 is 6. So I'm now going to go through and I'm going to rewrite this because I can take a 6 out. And what is 24 divided by 6? Well, I get 4x minus 18 divided by 6 is 3. And that is factored out. So, and these are the steps that we look for. Next, we're going to factor out 1/2 out of this. So I'm going to go through and I'm first of all going to take 1/2. And basically all that you do is you think of each one of these terms and I take 1/2 divided by 1/2 is 1. So I have 1x plus, if I take 1/2 out of 3/2, I will have 3 left over, right? I have 3 1/2 segments in 3/2, so plus 3. And here it is, 1/2 x plus 3. Notice I put 1x. You could also just leave it as just x. And these are the various steps that you rewrite and we distribute through to make sure that it works out. Next one says factor out a -2. So again, I'm going to go through here and I'm going to say -2. Well, actually I'm going to say -4p divided by negative 2. And I get 2, right? So I'll have 2p. So I'll have negative 2 times 2p. And then plus, and let's just take 10 divided by negative 2. And I get negative 5, right? So plus negative 5. And then I could see if this goes back again. So negative 2 times 2 is negative 2p, or negative 4p, which is what this is. And negative 2 times negative 5 becomes a positive 10. So when I distribute this out, it does work. But this is what it is in factored form. And here we go. And the last one is match the algebraic expression on the left with the factored form on the right. So I'm going to go through here and figure out which one of these things here works for each one of these. So what I recommend doing is, first of all, just looking at this one here, and I can take out a 6 out of both. So this would be 6, and then 12x divided by 6 would be 2x, plus 6 divided by 6 is 1. So I have to look here which one of these matches, and I see plus 1. It looks like C. Oh, well, there you go. C goes with 1. But you can see how I did all of these. Then I would look at this one here, and let's say that I take out a 6. So I could do 6, and then I have 2x minus 1. And so that's B. And then for this one here, they both have a negative, so I'm going to take out a negative 6 this time. This is for number 3. And that would be 2x plus 1. Because negative 6 times positive 1 is negative 6, which is what I'm going for here. And that's this one here. And then finally, I'm going to take out a 6x, or a 6, I'm sorry. And I have negative 2x minus 1. We'll see if there's any that work with this one. So this one here, if I look, I want to have a positive one, right? None of these work. But if I make this a negative sign here, and I make this here a positive, and this becomes a negative, this would in fact work, wouldn't it? Because that would become negative 12x plus 6, which is what this is here. And that's basically what we're doing in this little extension activity.